So we'll move on to the other color chart now. With those 8 colors listed in the first image, you can mix the warm and cool primaries plus black and white. You can mix almost every color that exists and every color that is available, except for some very vibrant, exceedingly synthetic colors, but they're not natural colors. So there's if you have the handout for this, is the one on the left, the chart that you're seeing with the different lines of squares, is chart 2, and chart 3 is on the right side there. And what I've done, and we'll just take the top row as the example, is I have pure cadmium red on the left square and a pure warm green on the right square. Then the square next to the pure cadmium red has a little bit of green in it. Next to that, it has more green in it. In the middle, the square you see has equal strengths of red and green, so that it's kind of lost its identity as either red or green. And then it turns out, if we'll start now from the warm green to the left of that, it has a little bit of red, and to the left of that, it has a little more. So this is crossing complements to create impurity. So we're dealing with colors that are complements of each other's, which are opposite of each other on the color wheel. The complement of red is green, the complement of green is red. And I'm crossing complements by adding elements of one side, let's say the green, to the red, and in different increments. So if I read what is going on in the top line on chart 2 on the left-hand side, is we've got a pure red, pure warm red to start with. Then we have a slightly impure red that is on the warm side of neutral. Then we have an impure red that is a little bit on the warm side of neutral. Then we have an exceedingly impure combination, which doesn't really have an identity as red or green, but that's the color you get when you mix those two together. Then continuing on, we have a green that has a fair amount of red in it, so it is a somewhat impure or somewhat impure green. Then we have the green next to that, which has a little red in it, which is a slightly impure green. And then we have the pure green. So the shift goes from going left to right across the top, pure to less pure to impure to less pure, back to pure. Because all those colors were warm, the temperature remains the same throughout. The next square down, all I've done is take the complements of red and green and reverse them temperature-wise, so that we're in the second row. The first red there is alizarin crimson, and then the square on the right side is an example of a pure cool green. And I've mixed them in the same way. Then just going down, we've got warm yellow pitted against a warm purple. Below that, a cool yellow pitted against a cool purple. Then we've got a warm blue pitted against a warm orange. And then we've got a cool blue pitted against a cool orange. So they all do the same shift in terms of purity, but in relation to temperature, there is no shift, because within each horizontal line, the temperature remains the same. When we look at the chart next to it, chart 3, what is going on is that I'm now taking, again, the warm red, but I'm pitting it against the cool green. Below that, the cool